Hello, welcome back to the next section, Clustering with Docker Swarm. We will start this section by explaining the concept of server clustering and then introduce you to Docker Swarm and its most important features. Moving ahead, we present how to build a swarm cluster from multiple Docker hosts. Also, we will be exploring advanced swarm features and deploying the Docker Compose configuration on a cluster. Then we will be introducing Kubernetes and Apache Mesos as alternatives to Docker Swarm. Finally, we will be dynamically scaling Jenkins agents on a cluster. Now we move on to the first video of this section, server clustering. In this video, we are going to introduce the concepts of server clustering and Docker Swarm. A server cluster is a set of connected computers that work together in a way that they can be used similarly to a single system. Servers are usually connected through the local network, with a connection fast enough to ensure a small influence of the fact that services are distributed. This image presents a simple server cluster. A user accesses the cluster via a host called the manager, whose interface should be similar to a usual Docker host. Inside the cluster, there are multiple worker nodes that receive tasks, execute them, and notify the manager of their current state. The manager is responsible for the orchestration process, including task dispatching, service discovery, load balancing, and worker failure detection. Docker Swarm is a native clustering system for Docker that turns a set of Docker hosts into one consistent cluster, called a swarm. Each host connected to the swarm plays the role of a manager or a worker. Technically, the physical location of the machines does not matter. However, it's reasonable to have all Docker hosts inside one local network. Otherwise, managing operations can take a significant amount of time. Regarding the terminology, in swarm mode, a running image is called a service, as opposed to a container, which is run in a single Docker host. One service runs a specified number of tasks. A task is an atomic scheduling unit of the swarm that holds the information about the container and the command that should be run inside the container. A replica is each container that is run on the node. The number of replicas is the expected number of all containers for the given service. Let's look at an image representing the terminology and the Docker Swarm clustering process. We start by specifying a service, the Docker image, and the number of replicas. The manager automatically assigns tasks to worker nodes. Obviously, each replicated container is run from the same Docker image. In the context of the presented flow, Docker Swarm can be viewed as a layer on top of the Docker engine mechanism that is responsible for container orchestration. In the sample image, we have 3 tasks. Each of them is run on a separate Docker host. Nevertheless, it may also happen that all containers would be started on the same Docker host. Everything depends on the manager node that allocates tasks to worker nodes using the scheduling strategy. Docker Swarm provides a number of interesting features. Some of the features are load balancing, dynamic role management, dynamic service scaling, failure recovery, rolling updates, 2 service nodes, namely replicated services and global services, and the last feature is security. That's all about server clustering.